802.11n is a big deal. Big deal for the enterprise networking market, not just for wireless LAN. Now with 11n, Wi-Fi comes of age. The performance that we've come to expect, the predictability of per user connectivity we've come to expect on a wired medium is now possible on a wireless. There's a big pipe, so you have enough capacity. You have capacity almost like fast Ethernet for every user, but at the same time, you also have the reliability, predictability, combined with the mobility to allow users to roam anywhere on your network. Now, Meru Networks has spent last 5 to 6 years in making that architecture robust to make that wireless infrastructure as comparable to wired, but as predictable, as reliable as wired infrastructure. And that's why thousands of our users world over are confidently able to migrate to a wireless LAN to support that mission critical applications that they were once running on wired medium. Not just that, they can also run some applications that they never thought possible on wired. So while we have made the infrastructure architecture very robust, in last 12 months, we have concentrated a lot more in actually improving the management and operation products for the wireless LAN. Now, if you really look at enterprise networking market and try and calculate the cost of wireless infrastructure, what you'll find is that the useful life of an infrastructure is about 3 to 5 years, and typically after that, either you replace your wireless LAN or there's a next PHY that you need to look at supporting on your infrastructure. But the cost of wireless LAN infrastructure or wireless LAN is not limited to infrastructure. While 40 to 45% of the cost is infrastructure, it's actually the management and operation of the network that ends up taking 60 to 65% of your budget in 3 to 5 years. So let's talk about the management base. There are two pieces here. One is reacting to user demands or user complaints. So while you have an infrastructure that supports all your mission critical applications, when the users complain about not being able to connect, you need to do something to help them out. And these are usually the reactive mechanisms, because user has complained, you go to the network management system, you try and find out what was the likely cause. What we did earlier this year was we introduced an EasyRF 2.0 network management platform, which allows you to go back, rewind, and recreate your RF environment so you can now find out what the root cause of the problem was for the user. We also created management signatures. So not only are the users able to take advantage of other large-scale networks that we have studied very carefully, where we have studied the pattern of different network management events and have tried to correlate it and create a management signature, they're also able to save a lot of time so that they don't have to go back every time and find out what the root cause is. The system tells them that here are the likely causes, here's where the link is broken, this is what you need to go and focus. So the time of managing for the reactive portion of the management was cut by half or more. Many of our customers have large-scale distributed environment. There is no way that they can actually go to that location where the user is experiencing problem. And by the time they go there, let's say a couple of hours, a couple of days later, RF environment has changed. So what the system does is captures all that information, stores it for the user, and now the network management can rewind, literally rewind, and say, okay, what happened on Thursday at 4 p.m. is something I'm able to see on Monday at 9 a.m. and then find out the root cause and help diagnose the problem in the network, and before they affect the users in that given area, you're able to do something about it. But what we are introducing in the market is now the proactive diagnostic. Reactive is all good because it helps you cut down the troubleshooting cost, it helps you help your users, but it's really proactive diagnostics which actually allows you to come up with a network that you're very confident that before the users show up on your network, you'll be able to do something about fixing the problem. So in other words, how do you make sure that before your users get on your network, you're able to rule out any of those root causes that can affect the performance of your wireless network? As I was mentioning earlier, now wireless LANs are as reliable as wired infrastructure. But then you have to measure this reliability. You have to be very confident that I'm providing a pipe so that my users, when they come with their devices, they're able to support or they're able to run all the applications the network was designed for. Let's step back and look at some of the industry examples. If you think about a nurse that's trying to make a call in an operation theater, let's say at 8 a.m. on Monday morning, and finds that the call is not going through, the nurse will contact the IT department, the network manager will try and diagnose the problem, and it may be that it's too late by the time the network manager is able to help that nurse. Now, what happened here was this call could have been a matter of life and death for somebody. Either the nurse had to leave that operation theater, go back to the central nurses station to take care of the problem, or had to rely on some other means of communications which were not real time. In either ways, the network actually failed to help or serve that nurse who needed it at that very moment. Now, how do you make sure this kind of a problem doesn't affect your users, and you're able to make sure that your network is going to operate or is available for the users before they come on the network? And that's why we're introducing Services Assurance Manager for proactive diagnostic. Now let's go through how the product works. Now Meru Networks, all access points are deployed on a single channel. And that's why sometimes it's commonly referred to as single channel architecture. Basically, when all your access points are on a single channel, the central controller is able to coordinate the access between different access points, but also make sure that there is no co-channel interference by design. But it also provides a lot of simplicity in the design, but it also provides a very, very good tool, a very, very robust architecture for management. Now let's take a look at how Service Assurance Management, which is a proactive diagnostic mechanism, takes advantage of that architecture and builds on it further to allow network managers to be able to centrally diagnose the problem before it affects the end users. Now, if you look at on this picture, you have access points. There are 4 access points all deployed on the same channel. All of these access points are serving their clients, which is shown by the laptops that are connected. Now, these could be any devices. These could be phone, laptops, just a normal environment with access points on same channel on a floor and all access points serving their clients. Now, Services Assurance Manager runs on a services appliance, SA1000. And that appliance basically has the software for the manager running on it, which has 2 parts. One is the server part, one is the client part. Now, basically, that Services Assurance Manager instantiates a client on one of the access point in the network. So while this access point is serving other clients, is able to serve as a client to a neighboring access points. Once this virtual client is initiated on one of the access point, the other access points in the system just see it as any other client. They cannot tell the difference whether it's another access point advertising itself as a client or is it another laptop that entered the network. A neighboring access point would pick up this virtual client, will send the packets back to the controller. The controller would send it back to the server part of Services Assurance Manager. So not what we have done is we've created this end-to-end loop of Services Assurance Manager instantiating a client on one of the access point that becomes a virtual client to the neighboring access point. Neighboring access point picks up that packet, sends those packets back to the controller, and via your backend infrastructure, that packet goes back to the server. Now, the server doesn't have to be on the same layer 2 network. In fact, it can be anywhere. It's over a layer 3 network over the internet that packet makes it back to the server. Now, server is able to tell that yes, this end-to-end packet, this end-to-end loop was completed, and all pipes are clear, and all pipes are able to are open for basically the network is available for any kind of a communication. What it also does is now you're able to point out the problems. If, for example, the neighboring access point was not available, the server would come to know. If the controller was down, the server would come to know. If anything was broken in the backend, like if the Radius or DHCP server was not available, the server would come to know. If the VLAN configurations were not done right, the server would come to know. So not just that, but many other problems that could affect the user's connectivity, availability of the network, they become known before the users come on your network. And this is what we are introducing in the market. And this is a proactive way of making sure that your network is available before your users come on the network. Now, let's look at the term services assurance. Why a term like that for a product like this? It's not just a proactively diagnosing, it's not just a proactive diagnostic system. It also allows you to tie in your business critical applications or the services that you have between divisions to wireless LAN networking. If you run a test on a network, say every day in the morning at 8 a.m. and typically the users come in at 9, or if you're trying to run this test before the students come into a classroom to take their online test, what you're able to do here is actually give that performance assurance that my network is available before the users actually come on my network. And this is the first time in the industry that we are able to tie in the business objective, business requirements to the wireless LAN infrastructure.